are the fiberglass rearing tanks in the main rearing room of the Dunn Hatchery at Pyramid Lake. At present, there are approximately 245,000 coho being reared in these tanks. Rodney Hawley, the supervisor of the hatchery, is showing some of the fish that have hatched out approximately 4 weeks ago. These fish were obtained from Summit Lake in the form of eggs and flown to this hatchery where they were incubated for about 3 weeks prior to hatch. These Lahontan cutthroat are on the threatened species list and are a wild stock of fish, not domesticated to hatchery rearing as the rainbow trout is. Part of the daily routine includes the sampling and testing of the water for quality. Here you see Adeline Davis, one of our fish culturists, taking a sample of water and doing a dissolved oxygen test to determine the amount of available oxygen to the fish being reared. These samples are taken at strategic points throughout the hatchery on a daily basis, as it is critical to monitor our water because of the unique nature of this hatchery. Most hatcheries are a single path system, having a source of water from, for example, a creek or river entering the hatchery and flowing through once and discharging at the other end. Because of the semi-arid climate and lack of water in the surrounding Pyramid Lake area, the hatchery had to, had to be designed to reuse the water over and over. This reuse system necessitates these careful chemical tests that are being done. This particular dissolved oxygen test is using the Winkler method and is based on a color property. Other tests in addition to the dissolved oxygen tests are done in this laboratory. Some of the parameters we include are pH readings, temperature readings, ammonia nitrogen, nitrate, and nitrite levels. In essence, the hatchery works as follows. The water is stored in a 100,000 gallon water tank elevated above the hatchery. The water gravity flows from this tank to the rearing area, where it is utilized by the fish and then discharged into cement gutters along the rearing room. These cement gutters then channel the water to a biological filter. This filter is approximately 10 feet deep and contains special media which house bacteria for the removal of ammonia. Ammonia is the main excretory product from the fish and is highly toxic. The bacteria take the ammonia and break it down first to nitrite, then to nitrate. The nitrate is essentially a non-toxic chemical until you reach extremely high levels. This never occurs in the hatchery because of a constant make-up water supply of approximately 2% per day. This water is obtained from 3 deep wells sunk in the surrounding area. These wells go approximately 400 feet deep into the earth to obtain good water for the hatchery system. In addition to the Lahontan cutthroat restoration program that the tribe is involved with, we are experimenting with a commercial fisheries program utilizing coho salmon. Our efforts are directed towards determining if coho salmon can be successfully reared in a hatchery such as the one you're seeing for approximately 6 months and then transferred to Pyramid Lake for an additional 6 months of rearing prior to reaching a marketable size of 3/4 of a pound. In this program we are trying 3 alternate methods, one being a system of net pens anchored in the lake itself, utilizing the natural properties of the lake to rear the fish with some supplemental feeding, utilizing a raceway system on shore from which water from the depths of the lake is pumped into and then discharged back into the lake. And the third method is a release recapture system where the silver salmon or coho salmon are planted in the lake and then will return on their own to the fish handling facility at the end of the Truckee River where these fish could possibly be marketed. Here's Tex Williams, another fish culturist of the hatchery, taking some water samples and determining the amount of ammonia present in the water. This test is of crucial importance because it tells us the effectiveness of our filter. There has to be a certain percentage of ammonia removed in his water samples of the sample that is taken prior to entering the filter and just after exiting from the filter. Here he is using an Orion analyzer to make his determinations. All the fish culturists that operate the David Dunn Hatchery are members of the Pyramid Lake Paiute tribe and have received on-the-job training for their technical expertise. Since the startup of the hatchery, we have conducted several classes in conjunction with a local community college, and in addition to receiving on-the-job training, have received college credits for these classes. These classes range from fish physiology and fish pathology all the way to general aquaculture production management courses. It is through these classes that the tribal members learn techniques such as you are witnessing. This water quality lab is also equipped with pathological equipment to test for a variety of diseases. The fish culturists are trained not only in recognizing a diseased fish, but also performing an external and internal autopsy, and then getting into more specialized areas of plating the fish out for bacterial or viral pathogens. Diseases are of extreme importance in a recirculating hatchery because of the reuse concept. Here you see outdoor swimming pools that are part of an addition to our main hatchery complex. These pools are commercial pools of the doughboy variety and have excellent application to fish husbandry techniques. In these three particular pools we are rearing coho salmon, which is part of our research program for the commercial fisheries potential. Here you see the fish are approximately 4 to 6 inches long, and they have exhibited excellent growth patterns in our hatchery. In order to try and catch the fish, we are doing a process known as chumming by tracking the fish towards the nets with some fish feed. The pipe spurting the water out is an airlift pipe, and this pipe's main function is to increase the dissolved oxygen in the tank by injecting the air into the bottom of the tube and then lifting the water and exiting it out in the spraying fashion. These fish are ready for planting into the lake in one of the 3 research areas. In a reuse hatchery, mechanics play a large part in the operations. As part of our daily routine, any pumps, motors, and other equipment have to be serviced. Here some of the fish culturists are preparing to backflush our biological filter. This is done by using a small high pressure pump such as you see the supervisor starting and spraying the filter down. This takes any of the solids that have settled into the biological filter or areas of large bacterial buildup and breaks it loose to prevent clogging of the filter and possibly creating an anaerobic situation where hydrogen sulfide could be produced. As before mentioned, all of the water enters the filter via cement troughs built into the floor of the hatchery, and then, after passing through the filter, exits to a sump directly beneath the floor you see, where 2 turbine shaft pumps take the water and route it back up to the storage tank for future use by the fish. On the way up to the storage tank, however, there are several processes that are acted upon the water. One is the water passes through 10 ultraviolet lights that are acting as a sterilizer to any fish pathogens in the water. In addition, when the water enters the top of the tank, there is a series of aerators which replenish oxygen that has been deleted by the fish and the bacteria themselves. The filter you see is divided into 2 types. The plastic active fill rings you see here, which are designed to create approximately 30 square feet per cubic foot, and the type on the other side, which are porcelain saddles. We have found this type to be a more effective house for the bacteria, as it offers approximately 59 square feet per cubic foot of surface area, and thus allows a higher percentage of bacteria to grow and remove ammonia from the water. The water in this trough has been purified and is going back into the sump. In operations such as the one you're seeing of back flushing the filter, the waste products are discharged by a series of valves to 2 waste settling ponds, approximately 1 acre apiece. Because of the high solar heat content in the Pyramid Lake area, the water evaporates from these ponds and thus no discharge leaves the Pyramid Lake Hatchery. One of the problems found in the reuse system is, in this area in particular, we get a heat buildup during the summer months. To combat this, we have installed a chiller which will keep the system in cool operating temperatures. Peter Azevedo is presently cleaning the troughs where the tank water discharges into. It is a constant housekeeping chore to keep all areas exposed to water clean, not only from the possibility of introduction of disease, but any growth, whether it's of an algal type or bacterial type, is consuming oxygen, which is all important in our fish rearing process. This is the incubator room. As you can see, the cameraman is having a hard time walking. These incubators are of the Heath Technic variety, and this wall of 7 incubators can hatch over 1.5 million Lahontan cutthroat eggs. This room also houses the UV filters you see numbered above, and 2 additional auxiliary rearing troughs below, which are currently housing some 3,000 coho salmon. The Lahontan cutthroat eggs, when they are taken from the egg sources, which up until recently has been solely Summit Lake, the eggs are flown that day when they are spawned to Pyramid Lake and put in these trays. Approximately 15,000 eggs per tray will be developing for about 20 days at roughly 52 degrees Fahrenheit. At this point in time, the eggs will hatch out and the fish will remain in the tray for an additional 2 to 3 weeks, depending upon the temperature, absorbing a large yolk sac which is attached to the fish. At that point in time, it is transferred to the fiberglass tanks in the main rearing room. This is a shot of the main storage tank above the hatchery site. It's 100,000 gallon capacity, which gives us reserve in case of a mechanical failure. And the pipe circumventing the tank is where the water exits through aerators. You can see in the distance Pyramid Lake. It covers approximately 110,000 surface acres. The land is semi-arid and it's comprised mainly of sagebrush and small juniper trees. Directly below is the hatchery facility and has been determined to be a very successful hatchery under the conditions that have been imposed upon it. The facility was built in 1974 and was named the David Dunn Hatchery after one of the original workers lost his life in attempting to obtain eggs for spawn for the first egg take. Down below the hatchery is a small town named Sutcliffe. Population is approximately 80 people. In 1905, Derby Dam was constructed on the lower Truckee River to divert water to the Newlands irrigation project for agricultural uses. This diversion took large quantities of water from the Truckee, which in the past had entered Pyramid Lake. With these diversions, the lake began a rapid decline in elevation. From 1905 to 1976, the lake has dropped some 80 feet. With this drop, several problems occurred. One of them was that a delta was formed where the Truckee River entered Pyramid Lake, creating a major migratory obstacle to the upstream spawning fish. This problem worsened until around 1940. The Lahontan cutthroat actually became extinct in Pyramid Lake because of this barrier. Another effort of Plights fishery program is to create a commercial fisheries on the reservation to put the whole program on a self-sustaining basis and create an employable situation. As part of that program, you see newly constructed a series of net pens anchored in the lake. These net pens are modular in design, and this present system has 12 pens, 20 feet by 40 feet by 15 feet deep. It is anticipated that the coho salmon, after leaving the hatchery at approximately 6 months of age, will be placed in the net pens, and the fish will remain in there for approximately 6 more months until they attain a marketable size. The pens have an auxiliary use for holding Lahontan cutthroat in the restoration program for a delayed release. Releasing the Lahontan cutthroat at a larger size will increase their survival rate in Pyramid Lake. The entire system was constructed by tribal members working at Plight. It is an extremely strong system designed because of the tremendous winds that are encountered during the winter months. This program of net pen feasibility has only been attempted in the northwest, in the Puget Sound area of Washington State. There they have tides and strong currents to deal with. In our situation, we have tremendous surface waves, sometimes attaining a height of 10 feet, which we battle. The system is moored via a series of 12 cables, which you see going to the large buoys. From the buoy, another cable goes down to a 3,000-pound Danforth anchor with 2,000 pounds of chain attached. Each pen has a 5-sided nylon net suspended several feet up to prevent jumping out, and eventually there will be a net placed across the top to discourage predation from birds. It should be noted that in the center of Pyramid Lake is Anaho Island, which is a national wildlife refuge for the black cormorant and the white pelican. Each year, thousands of these birds migrate north in the spring to Anaho Island, where their rookeries are located. Here you see the structure of the pen system. We are recycling used tires by filling them with a foam-filled product and then mounting them underneath wooden walkway structures. This gives us an economical pen system, yet very durable, as these tires should give us many years of wear. There is a 5-man crew which mans the net pen systems and associated hardware. In addition to being trained as fish culturists, they also must have mechanical orientation to maintain these facilities. Just offshore you see the research building. On that facility that just passed by was the game warden's trailer. There are the water storage tanks and the hatchery further uphill. Now we're approaching the town of Sutcliffe, where the office of Plight is located. You can see from the film that the area is a semi-arid climate with small shrubs and mainly sagebrush and small juniper trees being the predominant species. That's it. Well, maybe something else is coming.